Yeah, in the hot summer, our materials can make people's home be cooled down and good looking at the same time.
Hello, I'm Allison Tao from the American Chemical Society. Welcome to this media briefing from ACS Spring 2023. For those of us in the Northern Hemisphere, warmer temperatures are just around the corner, and on a hot summer day, the cold blast of an air conditioner can be a welcome relief. However, these AC units require large amounts of energy and can leak greenhouse gases. At the ACS meeting, scientists are reporting an eco-friendly alternative. They developed a colorful plant-based film that gets cooler when exposed to sunlight. The film comes in a variety of textures and bright iridescent colors. The material could someday keep buildings, cars, and other structures cool without requiring external power. To give us more insight on this work, we're joined today by Dr. Qingchen Shen from the University of Cambridge. Thank you for joining us.
And thank you for the invitation.
The films you developed can achieve what is called passive daytime radiative cooling. Could you briefly explain what that is and how it keeps surfaces cool?
The passive daytime radiative cooling is a renewable cooling technology, so which disperses heat to the extremely cold outer space without energy input. So as we know, there is spontaneously thermal transfer between objects with different temperatures. So this cooling technology is based on the thermal transfer between the materials with a high temperature and the extremely cold outer space using the thermal radiation. So you can imagine like at the daytime, if there is some materials absorbing no solar light, but dissipating its own heat into the cold outer space, so the thermal energy of these materials will decrease. So that shows the cooling phenomenon.
So most materials that can achieve passive daytime radiative cooling are white or have a mirrored finish. How are you able to achieve colorful cooling films without the use of pigments?
So like a previous work, they want to achieve like broadband reflection of the solar light. So that's the reason their appearance like white appearance or silver like appearance. But but our work, we want to achieve some color. But we don't want to use the pigment or dyes because they will absorb some of the sunlight and heat up, so they will counteract the cooling performance. To achieve the In order to achieve the color, we use the structure color based on the cellulose nut crystal. The cellulose nut crystal, namely the CNC, can be extracted from the renewable sources like wood. And once extracted, the CNC can be dispersed in water, and upon evaporation of this suspension, the CNC can spontaneously self-organize into the clustered ordering, and this ordering can be maintained like in the solid film. And based on this photonic structure, this dried film can reflect the visible light at a specific wavelength to show the color.
And so then could you talk about the structure of the films that you created?
Yeah, so the film, in order to for the practical use, we demonstrate the film with two layers. So the first layer is made by the CNC for generating the color, and then the second layer is porous, like a highly scattering isocellulose layer. So that layer, the purpose of this highly scattering layer is to scatter like unlight penetrate the first CNC layer like back. So in that way, the this bilayer film will show the color and the broadband solar reflection at the same time.
So what were some of the colors that your films were able to produce?
Now we can produce the red, green, and blue. So you can also adjust the CNC suspension to generate the different colors.
So you mentioned the plant-based materials using wood. So could you talk about what inspired you to use cellulose as a starting material?
So I think there is two reasons like inspire us for using the cellulose as a starting materials. So first, the cellulose is the most abundant polymer in the nature. So you can easily find the cellulose in wood, cotton, etc. And as natural materials, cellulose is sustainable and biocompatible. And secondly, is cellulose has some unique properties that are good for the radiation cooling. Like cellulose almost doesn't absorb solar energy, and it also has a very high thermal emissivity in the infrared band. And these both properties are very critical for achieving the radiation cooling.
So did you test the performance of the film materials? How effective are they at cooling?
Yes, yes, we measure the performance of our film. So the average sub-ambient temperature at the day during the day was around 3 degrees, and during the night was around 10 degrees.
Can the process for creating these films be scaled up?
Yeah, I think the process can for creating the film can be scaled up. Like we have managed to fabricate the CNC and the isocellulose film, bilayer film with a length larger than 2 meters, like by using a commercial relevant roll-to-roll process. I think with this process, we demonstrate like this technique can be scaled.
What are some of the potential applications of your research?
So the potential application, so first one is certainly like the film can be used for the thermal management for the building or cars. And I think they are vivid color should make them more compatible than the ones with the wide or the mirror-like appearance. And besides, uh, and considering the sensing ability of the CNCs, so the CNC as cellulose film may have the potential to detect some signals, maybe like environmental pollutants or the weather, like humidity, something like they can do some sensing stuff during cooling the building.
Before we wrap up, is there anything else you'd like to share with us about your research?
So maybe first we try to make a very smooth isocellulose layer, like the white layer. So then we tried to make some texture of the isocellulose layer, like to make the film good looking. So it kind of like a wood for have different texture, like they can use to decorate your home. Like we also want to make our film to have different texture, like to have yeah more applications.
Great. Well, thank you, Qingchen, for sharing your research with us.
Thank you.
Be sure to check out our other media briefings for ACS Spring 2023, which will be posted throughout the meeting at www.acs.org/ACS Spring 2023 briefings.